Okay, so welcome to the today's lecture, and today we will continue our topic, that is abrasive water jet machining. Okay, last lecture we have started this topic, and in that last lecture we have covered the introduction about abrasive water jet machining. Then we have seen mechanism of material removal, that is the working principle of water jet machining, uh, abrasive water jet machining. Then we have discussed the applications of this abrasive water jet machining, and we have started with the applications of abrasives in machining. Okay, so today we will start with the setup or equipment used for this abrasive water jet machining, and then in detail, one by one, we will discuss the all the elements of this abrasive water jet machining setup or system. Okay, so as I have mentioned in my last lecture also, this is setup or equipment used for abrasive water jet machining. Okay, and this diagram I have taken from the one of the reputed journal. Okay, so you can see here, as we require the pure water, compressed water, okay, pure high pressure water. So for that purpose, we have the this pumping unit. And pumping unit means what? There is one reservoir. Okay, so here I have shown that water inlet. So from reservoir you can take the water through the pump. You can pump it, and in that water treatment plant you can go for filtration and other removal of the contamination. Okay, that means the filtrant dryer is required. Dryer is required there. Okay, and to boost the pressure of the water, pure water, we require the one hydraulic unit, and that is called intensifier or the booster. Okay, which will increase the pressure of water up to 400 megapascal. Okay, so this total water treatment plant plus intensifier plus pump, it is called the pumping unit. Okay, then after that pumping unit, you will get the high pressure water. Okay, and that you have to give to the this unit. Okay, so here this is a mixing chamber. In that mixing chamber, you can use the high pressure water, and then in that mixing chamber you will have the one abrasive supply port. So for that purpose, here I have shown abrasive supply hooper. Through that, through this port hooper, you can insert the abrasive particles. Okay, and that will mix through this port in that mixing chamber. Okay, then in that mixing chamber, there will the there you will get the mixture of high pressure water plus the abrasive particles. Okay, so there you can say say that is a abrasive water jet. Okay, and then before nozzle you will get you will have the one mixture tube. Through that tube you will get the that high pressure abrasive water jet. Okay, and through the nozzle you can impinge that abrasive water jet uh, on the on this workpiece. Okay, by maintaining the sufficient distance, and that distance we are calling nozzle tip distance or stand up distance. Distance between the top surface of the your workpiece surface and the tip of the nozzle. Okay, and here you can see between this nozzle and the top surface of workpiece, we have maintained the given the gap. That is the SOD or NTD, and here the impingement or striking, okay, of the abrasive water jet. Okay, and after usage of this abrasive water jet, we have to use the abrasive water jet to the drainage. Okay, for the circulation or recirculation. So after that impingement on the workpiece, we need to reduce the velocity of that jet. For that purpose, we are using this component or element, that is called catcher. Okay, in detail we are going to see in the next slide also. Okay, just I will explain the setup. Okay, now we'll go for the one by one all these elements or I can say components. Okay, so just I have explained in the setup of abrasive water jet machining, abrasive water jet system, we have the four main elements. In that, first one is the pumping system, correct? Then, second, that mixing chamber and a mixing tube plus that port for abrasive. It is called abrasive feed system. Okay, first one is a pumping system. Second is the abrasive feed system. And then to impinge or to strike the water, that abrasive water jet, we need a abrasive jet nozzle. Okay, that is also important component or element of this abrasive water jet system. Okay, that is third. And the last one, to reduce the velocity of the used abrasive water jet, to reduce that, we need a catcher. Okay, so these are the four main elements of the our system. Okay, now I will discuss the one by one this all system. Okay, before that, whether my voice is and as well as my screen is visible to you all, say yes or no so that I can check in the uh, chat box. Okay, Vaishali More, I'm allowing all this thing. Whether my voice is audible to you all, chat box, I'm checking. Please say yes or no in the chat box so that I can go for further.
Yes, sir.
Sir, your voice is low. Okay. Okay. Through this PC, I think computer, my voice is not up to the high level. I will connect with the mobile, no problem.
Now, Pranay, whether my voice is up to the level or
Yes, sir.
whether
Yes,
still it is low.
yes, sir.
Okay,
Yes, sir.
now,
It is coming.
okay, I'm sending through the PC and I'm giving the voice through the mobile. Now, no problem. Okay, we'll continue. Okay, so now I was talking about the first component or element, that is a pumping system. Okay, so in that pumping system, why this pumping system is required? Because we need a high pressure water as well as the pure water. So for that purpose, we have to filter it, dry it. So for that purpose, dryer, filter, and this pump is required. Okay, to take the water from the reservoir and to boost or to increase the pressure of this water. Uh, to take up to the high pressure, we require the intensifier. Okay, which will increase the pressure of the water up to 415 megapascal. And to take the water from the reservoir, we need a motor of 75 HP. Okay, so already I have shown in the schematic diagram of water jet machine. There were the component intensifier, pump. Correct. The same components are used here also. Okay, because using this intensifier or the pumping system, we will get the high velocity jet of water, only water. Okay, we are going to mix the abrasive later on. Okay, so this is one basic component. Now, another one component, that is abrasive feed system. Correct. Abrasive feed system is what? Here, this system. Okay, I will talk about this now. Now, what is the role of this abrasive feed system? As we have seen in the figure, in the abrasive water jet system, this abrasive feed system, it delivers dry abrasive particles to control the flow rate of the uh, dry, uh, dry abrasive particles also. It is required. First is to deliver the dry abrasive particles as well as the to control the flow rate of this dry abrasive particles. We need abrasive feed system. Okay, correct. Now again, to control the orifice diameter in the mixing chamber. Okay, where we are getting the that water jet. Okay, which will mix with the here. I will show here also. Here we need our orifice. Okay, Here also I will show 1 minute. In this diagram, here is the orifice, correct? Here high pressure water is there. Here orifice. Okay, to control this orifice diameter, again to control the flow rate of this abrasive. Okay, and to deliver this abrasive particle, we need abrasive feed system. Okay, and by changing this orifice diameter, you can control the abrasive flow rate also. Okay, that mix in the mixing chamber also. Okay, to control the flow rate, to deliver the dry abrasive particles, again to control the orifice diameter, and to control the suction pressure in the there is drawback is there. Through this abrasive feed system, we cannot supply abrasive over the long distances. So many researchers have proposed or they are doing the experiments by using the directly slurry to feed over the long distance. Okay, as we cannot supply abrasive over long distance, so to overcome on this problem, many researchers as well as the people from the manufacturing sector, they have proposed and they are doing the experiment with using directly slurry. Okay, slurry means what? Mixture of the that water and the abrasive. Okay, and that slurry they are feeding, okay, over the long distance. Okay, but again, for this case, they require or it will require more power than the present system. Okay, water jet nozzle diameter normally it varies from 25 to 635 micron. Okay, water jet nozzle diameter. Okay, so this again the this statistic it is given by the researcher. Okay, water jet nozzle diameter it normally varies in between 75 to 635 micron. Okay, now this is about the abrasive feed system. Okay, and in that system we need a abrasive nozzle, correct? So abrasive jet nozzle. So now let us discuss types of abrasive jet nozzles and various functions of the nozzle in this abrasive water jet nozzle, abrasive water jet machining. Okay, now the function of this abrasive jet nozzle is, first one is the mixing of abrasive and water jet, as we have seen the in the diagram also, to mix the abrasive particle in that water. Okay, this is the first one function of the abrasive jet nozzle, and the second is to form the high velocity jet. Okay, to form the high velocity jet, and normally materials of the nozzles, abrasive jet nozzles, are tungsten carbide. Okay, that is WC, boron carbide also used, the sapphire also can be used, or very hard materials can be used for the manufacturing of abrasive jet nozzles, and that material should be resistant for the wear. Okay, so that property we should consider. Okay, no material of the nozzle should be wear resistant. Okay, and for high life of nozzle, normally a sapphire metal is used, because the same application I have discussed during the water jet machining also. Okay, sapphire is the material for nozzle, and it is used for the high life of the long nozzle. Okay, but this material, that sapphire material, is very expensive as compared to material the other metals. Okay, now come to the point. Now there are various types of abrasive jet nozzles. There are various types of abrasive jet nozzles. In that, again, this abrasive jet nozzle also called water jet nozzle, and in that, first type is single jet side feed nozzle. Single jet side feed nozzle. Okay, this type of nozzle, it is simple to make, but there is one limitation. It has rapid wear at exit part of the nozzle. Okay, so For single jet side feed nozzle, it is easy, simple to manufacture or to make, but it's a rapid wear of the exit part of the nozzle takes place. Okay, and normally
Hello, sir.
hello, hello.
Sir, voice is audible.
Okay, चुकून दे unmute. Okay, mute the answer. Okay, okay. I will repeat. I was talking about a single jet side feed nozzle. Okay, and this type of nozzle is simple to make, but it's a rapid wear of wear will be there. Rapid wear where at exit part of nozzle that is takes place, and it gives non-optimal efficiency of mixing of water and abrasive, as I have shown in the figure also. Okay, now this is a figure of single jet side feed nozzle. Okay, you can see here. Okay, now as I have shown in this particular figure, you can see abrasive particles or abrasives are coming from this port. Okay, abrasive particles are coming from this port, and water is coming from this central port. Okay, and both of them, this abrasive as well as water, they are mixing with each other. Okay, somewhere here. Okay, they are mixing here. So I have shown also mixing. Now after mixing, they are going out here. Okay, at the tip of the nozzle, you can see here. This is nozzle. Okay, you can see. Okay, now on the other hand, other side, abrasive particles are there. Okay, here, and in the middle, water is there. Correct. So abrasive particles are coming. These abrasive particles are coming in direct contact with this nozzle surface. Correct. इथून abrasive particle येतात आणि हे काय होणार डायरेक्ट कॉन्टॅक्ट मध्ये कुणाला येणार तर त्या नोझलच्या सरफेसला. Okay, that is the inner surface of the nozzle. So wear of the nozzle will be more. Okay, because due to the direct contact of these abrasive particles with this inner surface of the nozzle. So due to that, wear of the nozzle will be there, and you can see the distance between the bottom face of the nozzle, this one, and the upper face of this workpiece is the nozzle tip distance. Correct. And when this abrasive water jet hits or strike the this work piece surface, then only removal of material will take place. Okay, removal of material will take place. Here one point is to be noted that this stand up distance or NTD, nozzle tip distance, is not fixed always. Okay, when the jet is moving inside, okay, when jet is moving inside and it has moved sufficiently inside the workpiece, and here is say nozzle is there. Okay, and this nozzle, then this standoff distance will be this one, this much. Okay, this point we should be uh, clearly note. Okay, very simple. Okay, from the center we have to center of the nozzle we have to give the water, and from side we have to give the abrasive, and mixing of this water and abrasive will take place inside the nozzle. Okay, whether this point is clear? Madan Patil, can you say yes or no? Madan, whether my voice is there or audible to you or not? Madan Patil, whether you understood whatever I have discussed? Single jet side split nozzle. Aniket Mansude,
Yes, sir.
Aniket Mansude. Okay.
Yes, sir.
So shall I move forward?
Yes, sir.
Okay. Now, for the second type of abrasive jet nozzle is the annular jet central feed nozzle. Annular jet central feed nozzle. It gives better mixing of the water and abrasive particles. But in this particular case, mixing is outside the nozzle. Okay, mixing is here outside the nozzle. This is a nozzle. Okay, you can see. And mixing will take place outside the nozzle. And it is less accurate, or it gives less accurate mixing as compared to the earlier one. Okay. And in this particular case, cut or I can say curve width is higher as compared to earlier one. Okay, cut or that slot width, it is called curve width. It is higher as compared to earlier one, as you can see here also in this diagram. Okay, here water is coming from the side. Okay, this one, this one. Okay, whether this highlighter is visible, that pointer, whether you are able to see that pointer?
Yes, sir.
Okay, okay. Now, in this particular annular jet center feed nozzle, water is coming from this both side, this one and this one. Correct. And abrasive particles are coming from the central port. Correct. This is the reverse of the last one. And now, both of them, this abrasive as well as water, they are mixing here outside the nozzle. And you can see the divergence takes place over here. Here, divergence takes place. Okay, because of this divergence of jet, that is the abrasive water jet, the accuracy of the cutting reduces. Okay, as compared to the earlier one type of the nozzle, accuracy of the cutting will reduce. Okay, due to the divergence of this abrasive water jet. Okay, and because of this type of nozzle is less accurate. Okay, and normally this is okay, not used normally. It is not used for the machining because it having the some disadvantages. Let us discuss the third one. Okay, this is the third, that is multiple jet central feed nozzle. Okay, it is surrounded by multiple water jets. Okay, in a convergent annular. Okay, here you can see only two are there. From this port you can give the water, from this also. So like this, this abrasive port is there, no, at central. It is surrounded by multiple water jets. Okay, in the converging annulars. Okay, annulus you can say, and it gives higher nozzle life and better mixing. Okay, this type of nozzle. This is very important, and I will just explain it with the help of this figure. Okay. 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 Now, it is difficult to make. Now, if you talk about this only, then it is difficult to make, and its fabrication also costly. Now, in this particular case, you can see it gives higher nozzle life and better mixing. If you see in this particular figure, here water is in contact with this sides of the nozzle. Here you can see water is there. This is side of nozzle. Same here. Water is there, and this is side or surface of the nozzle. Okay, surface of nozzle. And the abrasive particles are not direct contact with the inner surface of the nozzle. Okay, if you compare this multiple jet central feed nozzle with the first one, single side, uh, a single jet side feed nozzle. Okay, in that case, abrasive particles were in direct contact with the nozzle surface. But here, water is direct contact with the surface of nozzle, and abrasive particles are moving through the central part pore. Okay, it is not in physical contact with the surface of nozzle, and that is why the life of the nozzle is higher as compared to other types of the nozzle. Okay, and here for this case, mixing is also inside the, you can see here inside the nozzle. Okay, mixing is also inside the nozzle, and this type of nozzle, it gives better mixing as compared to other one. And as you can see also, and here nozzle tip distance is shown over here. Okay, water is coming from this annular side from all around it, and this that is why this type of nozzle is known as multiple jets central feed nozzle. Okay, multiple jet central feed nozzle. So this is about the abrasive jet nozzle or water jet nozzle. Now come to the last part of the or element of the abrasive water jet system. Okay, catcher. Okay, now as we know that abrasive water jet, okay, abrasive water jet is coming at a very high velocity after the cutting the workpiece. Okay, after machining or after cutting the workpiece, that abrasive water jet is coming with the high velocity, and if it will strike the or it will hit the table on which you are going to machine the workpiece. Okay, so ज्या टेबल आपण वर्कपीस ठेवतो, ओके, तो जो खालचा टेबल आहे त्याच्यावर जर हाय व्हेलॉसिटी म्हणजे आपला ऍव्हरेज वॉटर जेट आलेलं आहे ते जर स्ट्राईक झालं, then it will penetrate inside that table also, and it will damage that table immediately. Okay, that average water jet, it will hit that table, then it will penetrate inside that table and it will damage that table immediately. Okay, and that is why what is done is that before it that average water jet really hits the table or the container or the tank at the water base, that is bottom, the velocity, okay, please listen carefully, the velocity of abrasive water jet is reduced to the minimum possible value. Okay, the velocity of abrasive water jet is reduced before it will strike to the workpiece table. Okay, and due to that, due to reduction of the velocity, one minute. Impact of that average water jet, okay, to the table, okay, which it is going to hit or the bottom of the water tank, and that impact is going to be reduced or it will go to the low, and that will not damage the table. So for that purpose, to reduce that velocity, we require the one element, and that element is called the catcher. This catcher, okay. I repeat, this catcher is used to minimize the velocity of the abrasive water jet before it strikes the base of the water tank, and so that tank does not get damaged. Okay, catcher will reduce the velocity of water jet. Okay, now this type of catcher, okay, this type of catcher, as I've shown in that figure also, it is normally used for two cases. The first case one is when stationary nozzle is there and your workpiece is moving. That time also you can use the catcher. And second one, if your nozzle is moving and your workpiece is stationary, that time also you can use the catcher to reduce the or to minimize the velocity of abrasive water jet before it will strike the that table where we are going to place our workpiece. Okay, understood? Okay, so this is about the abrasive water jet setup or elements that we have discussed here. Okay, whether understood or not, say yes or no so that I can proceed further. Understood or not?
Yes, sir.
Okay. Now let us discuss the next part. Next part. Now I'm going to talk about the what are the process parameters which will affect the performance of the abrasive water jet. Means what? Simply I will say which are the inputs. Okay, which will affect the performance. Okay, so it is also now these process parameters I am going to explain with the help of cause effect diagram or fishbone diagram. Okay, so you can see here. Here, I have shown the or I have drawn fishbone diagram for the abrasive water jet machining. Fishbone diagram is what? What are the causes for the performance of the abrasive water jet, and what are the its effect? Effects means the this output response. Okay, process response. Okay, and these are the process parameters. Okay, now these all process parameters I have divided into the some categories. Okay, now let us discuss this parametric analysis of this abrasive water jet machining with the help of fishbone diagram. Okay, now first parameter is that water. Okay, first is the water, and in that the pressure of the water and the flow rate of the water both are the parameters for this particular process. Okay, both are the parameters for this case. Okay, then the second is water nozzle. Now in that again nozzle cross section as well as the material of the nozzle, that parameters also affect the performance of the water abrasive water jet machining. Okay, now then third is the workpiece. Again the parameter workpiece parameter, again in that hardness of the workpiece, material property of the workpiece, whether this that workpiece material is ductile or brittle. So these parameters also we have to consider, and these will affect the performance of the abrasive water jet. Now performance means for your machining rate, that means the material removal rate, MRR, quality of your cut, curve quality, that is slot quality, and the depth of cut. Okay, you can say also like surface finish and accuracy also. Okay, MRR, surface finish. Okay, that means the quality. Okay, so to achieve that on that process responses. Okay, output process responses. These are the parameters which will affect this output responses. Now we'll move for the next one, abrasive. Okay, if we talk about the abrasive, again, whatever we are using the abrasive, their size, whether coarse size uh, abrasives or it may be the fine abrasive size. Okay, again type of the abrasive and flow rate of the that abrasive, these parameters also we need to consider, and these parameters also affect the performance of abrasive water jet machining. Okay, again abrasive feed nozzle is there. Okay, abrasive feed nozzle. Okay, in that again the cross section of that feed nozzle and the material of the abrasive feed nozzle, that point also or that parameters also we need to consider. Okay, for the performance analysis. So that purpose I'm telling it is parametric analysis. And apart from these all parameters, we have the cutting parameters also. You can see here cutting parameters also. In that again cutting parameters, your traverse rate or the feed rate, then angle of cutting, nozzle tip distance, that is SOD or NTD, and the number of passes. These all cutting parameters also affect the this machining rate, quality of cut, curve quality of cut, and the depth of cut. And the last one, the mixing tube, the diameter and the length of the mixing tube. That point also we need to consider for the parametric analysis. Okay. So this is a parametric analysis, or you can say a fishbone diagram of the abrasive water jet machining. Okay. So I request you all to within 2 minutes, please draw this. Okay, because this diagram you will not get in any book. Okay, this is I have taken from the one reputed journal. Okay, and I have drawn with the help of my pen and sketch pens. Okay, so please draw it faster, because through this diagram you can explain parametric analysis. And after this, one by one, I will explain how this abrasive, how this water nozzle pressure, how it will affect the MRR or the cut, depth of cut. Okay, that graph also I will explain. Please draw. Fast, fast. Are you writing or not? Say anybody, anybody say yes or no. Sonu ne. Then Samruddhi
Yes,
Deshpande.
sir.
That. Okay, please draw. Madan Patil. Madan Patil. Are you with me or not? Madan Patil. I don't know where he went. Uh, Look faster. We don't need to go in detail about the catcher types. Huh? But abrasive types also I have taken, but that is not in our syllabus. But we should know, okay? Because I think the nozzle, that part it will come in the automobile subject also. I think in that also same type is there. Types are there. Okay. You write down. Time being, I will just highlight this. Okay. So we have flow rate, pressure. Okay, of the water. Okay, and in that abrasive type, size, flow rate. Okay, then water and abrasive nozzle material, the cross section. Okay, or I can say the design. That parameter we need to consider. And if you talk about the cutting parameters, in that feed rate, SOD, okay, that will come. Okay, then we have the workpiece material, mixing tube, angle of cutting, traverse speed of the number of passes. This parameter we need to consider. So these are the very important parameters. Okay, because angle of that at what angle object that is hitting the workpiece, that also we need to consider. Okay. Now we'll go for the its analysis. In analysis means what? what is the effect of these process parameters on the performance? Performance is what in terms of MRR or depth of cut, that will see. Okay. Okay, shall we proceed further? Now I will take one first parameter and we'll discuss the effect of this parameter on the depth of cut. Okay. So let us see the effect of pressure, average water jet pressure on the depth of cut. Okay. As you can see in this particular figure here. Okay, here on the y-axis I have taken the depth of cut in the mm and the pressure I have taken in the on x-axis and this unit is megapascal. Okay, now in this the graph you will get one point here. You can see that is a critical pressure. Okay, this point is called critical pressure. This is the minimum pressure. Okay, critical pressure means what? Minimum pressure. Unless the kinetic energy of abrasive particles crosses this critical pressure, it cannot penetrate inside the workpiece material or workpiece surface. Okay, until and unless your kinetic energy object, it will pass the it will not pass this critical pressure. It will not start the machining. Okay, so minimum requirement is that your pressure should be up to I will say up to or more than that critical pressure. Then and then only machining will start, and then only that depth of cut will be formed on that workpiece surface. Okay. Now and after or beyond that critical pressure, your depth of cut will increase by increasing the pressure. This pressure. Okay, you can see. And after certain or after certain point, that depth of cut will be stabilized. Okay, so here first this graph and this is a non-linear graph. This is not a linear graph, straight line. Okay, this is curve. So up to certain point, your depth of cut will increase with the increasing pressure. But after certain this point, that depth of cut will be stabilized. Okay. Now if you take the higher critical pressure, you can see here also. Okay. So now critical pressure will increase by changing that average flow rate also. That is again I'm going to discuss in the next slide also. Okay. So once again I will repeat. Below this critical pressure, we can't do the cutting. Okay, or cutting will not take place. Again, this critical pressure will be different for the different workpiece material, and this depends upon the workpiece properties like hardness or ductility, etc. Okay, so we should achieve the critical pressure. Okay, and if you achieve that definite critical pressure or above the definite jet pressure, that machine depth tends to stabilize. That means here you can see here your stabilization will start. So above that, so there is a relationship between your water jet pressure and your machine depth. Okay, so above that definite jet pressure, that relation will get steeper with the higher abrasive flow rate. Okay, and if pressure this increase the pressure will be there, no, then it will lead to higher cost of pump maintenance. Then it will give lower efficiency and higher nozzle wear rate. Okay, if you increase this water jet pressure beyond the limit, then definitely that relationship between the machine depth and your pressure, it will get steeper. That means constant, stabilized. Okay, but during that you will get lower efficiency and there will be the higher nozzle wear rate due to the higher abrasive flow rate. Okay, So this point also we need to consider. And okay, now here this is about the abrasive water jet pressure. Okay, now I'll talk about the water jet pressure. Okay, now here through this diagram you'll get on y-axis I have taken depth of cut mm. Okay, and in on x-axis water jet pressure is there. Okay, again if you achieve the critical pressure, then and then only your depth of cut will start. So that purpose here also I have shown the critical pressure. Now depending on your nozzle diameter, the depth of cut also going to change. Okay, if you see here, this D1 is the larger nozzle diameter. Okay, if you increase nozzle diameter, then depth of cut will decrease. Depth of cut will decrease. Here you can see. Okay. But by increasing the water jet pressure, definitely depth of cut will increase. But after the certain limit, it is going to stabilize. Okay. So in this diagram, I'm once again clearing that D1 is the higher. Okay, as compared to D2. Okay. So no, if you increase the nozzle diameter, depth of cut will decrease. But water pressure increase, water jet pressure increase, depth of cut also increase. Okay, but after a certain point, it is going to stabilize. Okay, म्हणजे काय पुढे गेल्यानंतर फक्त कॉन्स्टंट राहणार याचा अर्थ. Now this part is I think already you all learned is the FM subject, and this is beyond the our syllabus also. But just I will highlight that. Okay, so there is a relation through the fluid mechanics that our abrasive flow rate, it is directly proportional to under square root of the pressure, and the flow rate is or water flow rate, it is directly proportional to square of nozzle diameter. Okay. Okay. So this point is I have taken for the your information only, extra information. And normally the abrasive, as already you know that abrasive flow velocity, it is up to the 300 meter per second. Okay. And also there is one relation. Your machine depth is there, no? That is directly proportional to your square of velocity and this reduce the depth. Okay, and so that purpose you have to maintain the critical value. Above the critical value you have to maintain that. Okay, and normally by increasing the depth, okay, where the mixing nozzle will be increased, and if you increase the depth, then mixing efficiency will decrease. Okay, selection of the type of the abrasive. Okay, so it is depend on the cost of abrasive, nozzle wear rate, environmental consideration, machine rate, and particle strength. Okay, so this point also we need to consider selection of the type of abrasive. Okay, which type of abrasive we can use. So for that purpose, we need to consider this point: cost of abrasive, nozzle wear rate, environmental considerations, machining rate. Okay, that is MRR, and particle strength. Okay, these relations. This is just I have shown for your information purpose. Okay. Now, the remaining part we'll discuss because still 3-4 points are there in that. We'll discuss in the next lecture. Okay. Whether you understood what I am discussing today? Say yes or no. Hello. Yama. Okay. 2:25 झालं तर आपण थांबायचं का? attendance घ्यायचे. Hello. We'll stop here. Okay. Before that, I will take attendance. Huh? Wait. Okay. Remaining part. Okay. Still, we need 10-20 minutes to finish that part. For that purpose, I have stopped. Okay. Now, beta, I will now. Don't leave group that this class. I will just note down your the roll number. Wait. Wait. Huh. Now present roll number from A division. Okay, from A division. From A division. कौन कौन है कौन? Please tell your roll number. Display 50. Next. A division. A5. Okay, next. Okay, in the chat box you can write down a roll number. From that I will take up immediately. Please, all of you, please write down your roll number in the chat box. 6 I have covered. A5 I have covered. Yeah. 6:35. 18 I have covered. 33. Service. 31. Everything I have covered. So which choice? Baha. And so on. Okay. This. Which choice? Sure. Etc. Which choice? Sumit Patware.
Yes, sir.
Please write down your roll number.
I have no roll number.
Okay. Sumit Patware. Okay. You were that year round student?
Yeah.
Okay, okay, no problem. Please take your roll number from the Yashin sir or CC Zado sir.
Okay.
Three. I will post this attendance on group within 10 to 5 minutes. If anybody remains, that time you can also tell me. I'm taking all 30 or 30 minutes तक करना. अरे डबल का देते हैं मस्ट. Choice. Okay. Now you can leave the group. Leave the class. Okay. Thank you.